gonna let my experience shine through here, really. So it's going to be a really quick talk. I'm going to talk about some of the efficiency savings that the engineering team have been able to make by adopting what's known as a microservices architecture. I'll try and not bore you with too much technical detail, don't worry too much. So if you kind of consider your traditional web application, you have a bunch of features. For example, presenting an application form that the user can enter some data in, storing some data so you fire off that data in a database so you've got that persisted, generating some docx documents as we've seen previously, and generating a solution. In a monolithic sort of architected application, you would bundle all those features in one app. So that lives in one place, it's one bundle, one code base. And if you want to change any of that, you're essentially changing that one entity. It's one piece, so it's one, as the name implies, it's monolithic. Now that actually makes sense in a lot of cases, and as a matter of fact, the first generation of Wealth Wizard products were developed in this way. So that's the Pension Wizard and the Retirement Wizard. And depending on the context of your team structure, your team size, and the sort of features you want to roll out, this actually can be quite optimal. But as you start to scale, as your feature requirements get a bit more complex, your product managers start to get a bit annoying, there's going to be a few issues. So one way to deal with that is to adopt the microservice approach. That took a long time to do, so. It's all downhill for me. But so yeah, so it's actually quite intuitive. From a high level, you're essentially splitting out the application into smaller applications. And it's important to note that from the user's perspective, there's still one coherent application. They don't notice the difference. There's just smaller applications servicing that wider purpose. So hopefully that was illustrated well. So why would we do this? I think all the benefits are actually really intuitive. Component reuse. I'll try to actually explain how that looks like in our case and give you something that's a bit more material. But this is something that's enabled by this structure, due to this sort of distribution of responsibilities. So another sort of enabler of adopting this architecture is having frictionless parallel work streams. Again, this is quite intuitive. You have several applications now that can sort of sit side by side, so you can distribute your workload in a way that is complementary to that sort of architecture. Another great sort of benefit that you get from this architecture is the ability to decentralize your failure points. So if you look back to your monolith, as I explained, you have one application. That goes down, it's a very bad day for everyone, we all go home. But in a sort of distributed architecture, obviously you have several places where if a component goes down, you can actually still service your application or most of the application's features if the remainder of your components are still standing. So again, a great benefit that you get from this architecture. And the last one, but my favorite, is a bit easier to work with because it's hard to write code sometimes. So reduced complexity is also a great benefit for developers. So in terms of Wealth Wizards, how does this look? The next generation of products, so that's the Robo Power Planner and the DB Transfer Wizard, which is a team that I'll be working on with, has a bunch of functionalities. So as I said, we've distributed these as microservices. So all these white boxes, you can sort of look at these as these services or these components to the wider system application. So you have a bunch of stuff that you want to do, calculating sleep, pension age, generating a solution, generating a document. And when it comes to shifting the context of the system to perhaps another application, so the DB Transfer Wizard, which has slightly different use cases or slightly different logic, there are certain things that are unique to the application. So you create microservices which kind of reflects the unique context of that application. So generating that user interface, the DB transfer, and the business logic, which is contained in that sort of far-right microservice. But as the beauty of this architecture shines, you have all of these components that you can reuse now. You sort of plug and play to create an entirely new application and really sort of allow that reusability that I previously talked about with. So if you were designing that system, that's how that would look. All those components in the middle are actually things that the application can need to service the user. So all that calculation of state, pension age, reused out the box edge, which is obviously a huge sort of efficiency boost for the team. And just to really sort of illustrate, I think, what Louis was talking about before with this golden vision of the architecture, where we have this entirely powerful and configurable system that we can sort of tailor, tweak, and heal, and plug and play these microservices as we need in an incredibly efficient way without having to rewrite entirely new products from scratch. It sort of looks like this. You have multiple tenants come in, you can sort of plug and play these components as you see fit, depending on your particular context. And this goes not just to support tenants, but even in terms of upgrading our systems. We now have the ability to have a flexible approach to that. We can sort of focus on subsections of that system, and obviously this is something that is incredibly flexible. So, just to close, a pretty picture in case microservices don't do for you. Just Tesla's electric car factory, which I think truly optimizes and sort of offers a nice parallel for the efficiency I think we're trying to strive with this architectural vision. And that's it.